Kita taka tadina dinata da kada din tatang kada din tadin tajam.
Meet Ravindra. He is a 5th year BSMS student at IISER Pune. He has been interested in ants from his 2nd year onwards. He has been observing them and has been fascinated by their strange behaviors. By the end of the 2nd year, he started documenting them with his camera. The variety of ants that are available on campus never fail to amaze him. These ants, for example, have elaborate grooming or self-cleaning behavior. They use their antennae to interact with others. What kind of information do they pass to each other? And these ants, they are somehow attracted to a place where a dog had urine marked earlier. Are they extracting some food? Scavenging for some essential nutrients? He also noticed that there are some ants that set out from their nest in large numbers in the morning, but there are also others which forage individually. What determines these differences? While some ants stay in the same nest throughout their lives, some other species go through large-scale migration of the whole colony. Are they migrating in search of better sources of food or in search of a safer location? Ravindra had many questions, and he started observing them even more keenly. He noticed that not all ants in the colony are always busy. While some are busy transporting food to the colony, there are others that stand apart, apparently not doing anything. But then they also serve other functions, such as defending the nestmates from thieves and predators. Ravindra wanted to understand the behaviors of different categories of ants in the colony. So he was often spending time in the library where he learned from E.O. Wilson and others about the structures of the social organization in insects. This enriched his observations. Here, for example, some worker ants in the colony are busy removing the soil from below to develop their colony space. Here is a scout leading a worker to a food source. It's technically called tandem running. These are soldiers, easily identifiable from their larger size at the opening of the nest, keeping track of the comings and goings. Ravindra could not help intervening, just to check whether these sleepy sentinels can indeed be provoked to action. Soon, he started focusing his attention on the interactions between ants. Their use of antennae in social interactions, their ability to recognize ants from other nests, and their willingness to fight, even to kill ants from other nests. Ravindra wondered about the world of ants. The fight for resources between species or even between colonies is understandable. But do they also recycle the chitin from the exoskeleton of the vanquished? Soon his attention was caught by the transportation strategies of ants. When a dead insect is small, it is normally carried or dragged to the nest. At other times, many ants come together to separate out the insect into parts which are easier to carry. And there are yet other times when hordes of them join together and pull a much larger creature to the nest. This particular species is so collaborative that they can immobilize and kill much bigger insects, and they carry the parts quickly and efficiently to their nest. Ravindra was curious, and to understand ants better, he started experimenting. He dropped some rice grains for the ants to carry. Whenever there are big hurdles for the small ants, other ants came and helped, just enough to overcome the problem. Once that is done, some depart, leaving the grain with just enough number of ants that can get it closer to the nest. Ravindra dropped some grains on paper also, and noted that just 2 ants are enough to drag the grain without help. Help from the nestmates seem to come only when the terrain is difficult. How do ants strategize and optimize their energies in transporting goods? Feeding ants and observing and documenting their behavior became a pastime for Ravindra. Ravindra's experimental attitude led him to explore further. He put a block in the path of the ants. There was some amount of confusion for some time, and then, surprisingly, the ants took a 180-degree turn and started to drag their loot in the opposite direction. Now Ravindra blocked that path also. Again, the ants took a 180-degree turn and were soon back to the older roadblock. Now what will they do? There was a lot of commotion and confusion initially. Meanwhile, there were some ants that had been running around who managed to find a way around the block. And though it did take some amount of time, the ants carrying the load ultimately got the message. And they started dragging their load around the block. If we can understand this group behavior and create algorithms for small robots to behave cooperatively and flexibly, they would be very useful in dangerous situations, like in mines to extract materials and to save lives of people trapped under debris after a devastating earthquake. Ravindra was now clear what he wanted to do with his life. He would be doing research on ants and social insects. He started reading up on recent research on ants. It is with a new purpose that he continued his observations. He recorded ant colonies that others would not even glance at. He started making detailed records of his observations on how a group is recruited for a specific task. He knew that ants leave chemical trails for other ants to follow. There are also times when they are moving in tandem, so there must be some information passed through contact also. He wanted to understand the flow of information between ants during group recruitment. This would be the key to the algorithm for the tiny robots of future. It is then that he went to work with Ravindra Gadakar in IISc Bangalore for his third-year project. Here he noticed these ants that go out in huge processions. There is some order in the apparent large-scale movements of ants. There also seemed to be some kind of single-lane traffic system when they are transporting food. He observed that there were some ants that move off from the path and just stand around. Are they guarding the path? Ravindra was not sure. Do their running speed vary depending on whether they are carrying food or not? Now, this was an easy question. He put a scale and started measuring the distances covered by these ants in different situations. And he wrote a paper on his observations and measurements, his very first scientific paper. When he returned to IISER Pune after the project, he went back to reading up more on ants. And then one day, he noticed ants doing some animal husbandry. He had read about it earlier. These insects are called tree hoppers. They suck the sap from the tree to survive, and they excrete a kind of nectar which is food for the ants. The ants, in return, nurse these tree hoppers and protect them from other insects which prey on tree hoppers. Is it the same ants that visit the same branch every day to attend the same tree hoppers? Or do they go to a different patch each day? How do we know? Again, Ravindra devised an experiment under guidance from Dr. Priya. Paint ants going to different patches in different colors. Observe them for many days. Not every day, perhaps a few days apart. He executed the experiment and found that it is the same ants that go to a particular branch day after day. Another scientific paper to his credit, while still a fourth-year student. He will go back to Bangalore for his fifth-year project and work under the guidance of Professor Gadakar. There is more that he needs to learn, especially about other social insects. He has to reach his goal of understanding information flow in ant colonies, and he should be capable enough to translate this understanding into information technology and robotics. He has many more years to go and hopes to fulfill his dreams.
Tin